Let's do H
first principles
over H.
Okay,
Oh, I forgot to do take.
so what we're going to do here is we're graphing absolute value functions. We can definitely use our calculator, but I'm going to stress for you guys the dot point packages at the top of 3F.2. So we've got the graph of y equals f of modulus of x and the graph of modulus of f of x. Difference between those two. But let's just start with graphing this quadratic. I would expect us to be able to do that. So if we want to graph a quadratic, firstly it has a positive a value, so that means it's going to open upwards. Okay, we can identify that. We can find the roots by making it equal to 0, factorise it, and apply the null factor law. So we've got two roots. Now the y-intercept occurs when x is 0. Okay, when x is 0, the value of y is also going to be 0. So the graph of this quadratic then has a root at 0 and at -2. It opens upwards. Okay, y-intercept of 0, here's the x, here's the y. And we could find that minimum point. It's going to have an x value of -1 because it's exactly halfway between them. And the y value would be 1 take 2, it would also be -1. So we've found the graph of that quadratic, just making a manual argument there. We can get that straight from our calculator. Now, for the modulus function, all right, you can read the dot points if you want to, and it can be useful to consider it. But all you're doing on this graph is making every negative value becomes positive and keeps its magnitude. So that means, I'll draw my axis over a little bit more. All right, so here's what the function looks like. They're the positive components. All right, they're already there. And this negative component, we just make it positive. Okay, because we're performing the modulus of it. So now the coordinates are x is -1, y is +1. We can observe that from our calculator. And if you follow the dot points along, it says keep the graph for when it's positive, reflect the graph in the x-axis for values less than 0, so that those values just get reflected up here on the x-axis and we discard what's below it. Points on the x-axis are invariant. That means these points do not move. These points, the roots, they remain the same. Now, if you were going to graph this function, what you would type into your calculator is modulus of x squared plus 2x. All right, that's going to produce the graph of that function. Okay, let's move on to this one, because this one's a little bit different, and we'll read the dot points for this. So this is your top box, the graph of y equals f modulus of x. So it says discard the graph for x is less than 0. All right, so here, that's what we have for x is larger than 0. It doesn't have that much of a curve. I've exaggerated that pretty badly. It's like this. So we discard that part of the graph. All right, that's the first dot point. And reflect the graph for x is greater than 0 in the y-axis. So all we're doing is reflecting that over here. That's what it looks like. Okay, that's y equals f of modulus of x. Points on the y-axis are invariant, so that's the y-intercept. That stays the same as it did on the original function. If you wanted to graph this function, you would need to type in modulus of x squared plus 2 times modulus of x. All right, f of modulus of x means you're substituting the modulus of x everywhere there is an x in the original function. So that's 3F.2. Use your calculator, but I encourage you to be familiar with the rules associated with it.